These are fossils. They're the skeletons, shells, and hard parts of animals that lived millions of years ago, and they're preserved in solid rock. But how exactly does that happen? Well, first, to understand that, we need to understand what a fossil is. And a fossil is simply a mold or cast of the hard parts of an animal. If you haven't watched my first video where I talk about igneous rocks, it's probably a good idea to watch that now. If you remember from the rock cycle, there are three types of rocks: sedimentary, metamorphic, and igneous. And fossils can only form in sedimentary rocks. Fossils like these ones are from organisms that are millions of years old. And when they died, they probably were preserved in something that's a lot more like mud than rock. Over time, that mud can turn into a hard, solid piece of sedimentary rock. But how does that happen? The oldest structure that humans have built is only about 11,000 years old, and it's in ruins. But yet these fossils show almost completely what the body structure of the animals were. That's because in geologic time, there's enough slow time to produce a hard, solid fossil like this one. Sedimentary rocks unlock the key to the past because they preserve information about exactly what organisms were there, the environment, and all sorts of information about how the rocks were formed.
Sedimentary rocks are those that have formed through deposition and solidification of sediment. And sediment is created by weathering and erosion. It's these processes that drive the formation of new rocks in the rock cycle. The first step in the formation of sedimentary rocks is the breaking down of other rocks, igneous, metamorphic, or sedimentary rocks themselves. You take an indurated rock like this, nice and hard rock, and you break it down into small particles through processes of weathering. Now you can have two kinds of weathering, that is mechanical weathering and chemical weathering. Mechanical weathering has no chemical component, so it's the physical breaking down of a rock. So that could be a rock fall, it could be frost, ice getting in between the cracks of a rock, breaking it up, or salt weathering. Chemical weathering, on the other hand, is the breaking of bonds through the medium of water. So water gets into the surface of the rock and chemically interacts with the crystal lattice in the minerals. Once sediments are created, you can have two different processes happen. The sediments can simply be transported out by a waterway into the ocean, where they'll settle out to form new rocks, or they can create soil. And soil is simply the addition of organic matter to that mineral component that was formed during the weathering process. So you see here there's lots of roots and things hanging out of this piece of soil. Now, if you want to learn more about soil, my friend made an amazing video about soil that goes into way more detail. And soil is really important because it's the basis for all plant life, and we depend on agriculture, which is growing food in soil. So I'll link a video here. Once sediments have been created and transported out into the ocean, that's where they have the chance to settle out and form new rock. Sediment can be transported in many different ways. By water, like rivers, lakes, and oceans. By ice, such as glaciers. And by wind, think sand dunes. If you live in a place that gets summertime thunderstorms, you may have seen how the intense rainfall can cause runoff and erosion. This runoff can carry sediments into larger bodies of water, like rivers, and eventually those rivers will reach the ocean one way or another. If you haven't seen it in person, it's pretty easy to do at home. Just take a jar and add some sand to it. Fill the jar with water. If you stir up the jar, you can see how the sediment will be suspended because the energy level of the water is higher. But if you stop stirring and give it enough time, those sediments will settle out. This is exactly how sedimentary rocks begin to form. Sediment is carried in water bodies until energy level is low enough that they begin to settle out. This can be seen in satellite imagery. In this picture, on the right, the Ohio River has a higher energy level and carries more sediment, but on the left, the Mississippi River is at a lower energy state and carries less sediment. Eventually, the Mississippi River will reach the ocean, where it disperses its energy and all the sediment falls out and goes to the bottom of the ocean. The sediment eventually settles out on the bottom of the ocean,
and begins to compact because of all the pressure of the water above it. Given time, geologic time, that is millions of years, that compaction would turn into cementation, and new rock will form. Weathering and erosion, sedimentation and compaction, and new rock formation is what drives this part of the rock cycle. Sedimentary rocks provide us with so much information, from what life used to be like on this planet to what the conditions were like when the rock formed. By studying and understanding sedimentary rocks, geologists were able to discover that sedimentary rocks actually exist on Mars as well. That means that water flowed over the surface of Mars, and perhaps at one time, Mars wasn't that different from planet Earth. In this video, we learned about fossils and how they're formed, the definition of sedimentary rocks, what weathering and erosion is, and about sedimentation and deposition. If you have any questions about sedimentary rocks, feel free to ask them in the comments below. Thanks for watching, and stay curious about the natural world.